Question: for how many positive integral values of n will the fraction 21n plus 4 whole divided by 14n plus 3 be non-reduced? A fraction is said to be non-reduced when the numerator and denominator have an integral factor common to both, because in that case we can cancel out the factor to get a new form of the factor, which is now called reduced. So basically we have to find out if there are any common integral factors that divide both numerator and denominator of the given fraction. We will solve this problem by two methods. Method 1. Let us examine the value of the fraction 21n plus 4 divided by 14n plus 3 for different positive integral values of n. When n is equal to 1, the fraction 21n plus 4 divided by 14n plus 3 is equal to 21 plus 4 divided by 14 plus 3, and that is equal to 25 by 17, and the value is 1.47. When n becomes very large, 4 becomes insignificant compared to 21n on the numerator and therefore can be neglected. So this 4 can be neglected in comparison with 21n. Similarly, 3 can be neglected in comparison with 14n because n is very large. Therefore, when n approaches infinity, the fraction becomes the limiting case when n becomes or n approaches infinity of 21n plus 4 divided by 14n plus 3, that is equal to 21 by 14, which is 1.4. So the fraction increases slowly from 1.47 to 1.45 when n varies from 1 and approaches infinity. This clearly shows that the numerator and the denominator of the given fraction cannot have any common integral factor besides 1. It cannot have a common factor of 2 because the fraction itself never gets a value of 2. Therefore, it cannot be reduced for any positive integral value of n. So the answer is, for no positive integral value of n will the fraction be non-reduced. Therefore, the answer is 0. The second method: if possible, let there be a positive integer p other than 1, which is a common factor of both numerator and denominator. Then p divides 21n plus 4 without leaving any remainder. This implies that p also divides a multiplied by 21 plus n, where a is any arbitrary integer. Similarly, p divides 14n plus 3 without leaving any remainder. Therefore, P also divides B multiplied by 14n plus 3, where B is also any arbitrary integer. Therefore, P divides A multiplied by 21n plus 4 plus B multiplied by 14n plus 3. Since both A and B are arbitrary integers, we can assign any value to them without loss of generality. So, let us assign the value of minus 2 to A and the value of plus 3 to B. These values are chosen by us to cancel out terms involving n. With these two assigned values for A and B, we can write that P divides minus 2 into 21n plus 4 plus 3 multiplied by 14n plus 3. Simplifying it, P divides minus 42n minus 8 plus 42n plus 9. Since 42n and 42n will cancel, we get P divides 1. The only positive integer that can divide 1 is 1. Hence, P is equal to 1. Therefore, the only positive integral factor that divides both the numerator and the denominator of the given fraction is 1. This means that the fraction 21n plus 4 divided by 14n plus 3 is fully reduced for all positive integral values of n. In other words, for no positive integral values of n will the fraction 21n plus 4 divided by 14n plus 3 be non-reduced. So the answer is 0.